O, już powinno być mnie słychać. Miałem mikrofon wyciszony, nie włączyłem go z powrotem. No nic, no to jeszcze raz mówiąc, odpaliłem tą transmisję troszeczkę szybciej, żebyśmy zdążyli na sam początek. Już czekamy na NASA, pokazane jest, czekamy na NASA, aż odpali transmisję. Obejrzymy ją sobie wspólnie, trochę sobie porozmawiamy na ten temat, trochę omówimy, ja trochę powiem, o czym oni będą mówić. I będziemy sobie razem komentować to wszystko na żywo. Zobaczymy, sam jestem ciekawy tych próbek, które przyleciały do nas z tej asteroidy Bennu, które mają kupę lat. O, już się zaczyna. Nie wiem, czy chcecie na dużym ekranie, czy będziecie chcieli na dużym ekranie, czy na... Ustawimy sobie jakoś na najwyższą. Czy chcecie na dużym ekranie, czy na małym? A może na dużym będzie tak lepiej. Jak będziecie chcieli, to wyłączę też kamerę, żeby nie zasłaniała ekranu, jak będziecie chcieli. Zobaczymy, jak to będzie wyglądało. No nic, w każdym razie już się zaczyna. Już jest starting soon, czyli wkrótce zaczęcie. Odsłonięcie próbek asteroidy z misji osiris-rex. O, zaczyna się już. Powiedzcie mi też, jak słychać, czy dobrze jest słychać samą tą transmisję po waszej stronie. Ja sobie ustawię to tak, żeby słyszeć, bo mam dźwięk z tego w słuchawkach. Transmisję słabo słychać, tak? No to już chwilkę, ja ją podkręcę. Jeszcze chwilkę, ja ją troszeczkę... A jak jest teraz? Teraz słychać lepiej transmisję?
Wow, don't be afraid to clap or cheer. Today is a celebration. And what you just witnessed was a glimpse
Wciąż słabo,
of
tak?
hard work and dedication from a devoted
Dobrze, to ja już to zmieniam.
They dared to pull off what some would call seemingly impossible, to gather our largest asteroid sample ever and bring it home safely to Earth. I'm Shaniqua Vereen with NASA's Office of Communications, and I will be your host today as we bring you
Sekundkę.
to the heart of the Johnson Space Center's Curation Lab, introduce you to some of the team members hard at work, and provide you with a first look at our initial findings. Thank you all for being here, and welcome to the much anticipated osiris-rex sample reveal.
A teraz jak będzie? A teraz Ola jak jest?
Alright, we'll kick things off and we'll start with a proper Houston welcome. I'm pleased to introduce to you Vanessa White, Director of the Johnson Space Center.
Thank you, Shaniqua.
Lepiej troszkę, czyli
And welcome
jeszcze
to
zwiększę w
NASA's
takim razie.
Johnson Space Center. We're here today for a very exciting moment in history. The sample reveal of osiris-rex. The Johnson Space Center has played a pivotal role in many firsts in human spaceflight, from landing the first person on the moon to supporting NASA astronaut Frank Rubio's
Ja miałem cicho głośnik.
371 days in space on the International Space Station.
Słuchaj, super, tak? To dobrze, to wracamy do oglądania. Pani dyrektor, jak dobrze słyszałem, dyrektor Centrum Dyrektor Centrum Johnson Space Center.
Home to America's Astronaut Corps,
Troszeczkę się zgubiłem teraz
mission
przez ten dźwięk.
operations at the Johnson Space Center. Our workforce also includes the world's leading sample scientists, and we curate the most extensive collection of extraterrestrial materials on Earth. We're honored to be joined by some special guests today. Please help me in welcoming NASA leadership, Administrator Bill Nelson, Director of Goddard Space Flight Center, Mackenzie Lystrup, and Director of the Planetary Science Division in NASA's Science Mission Directorate, Lori Glaze. They'll be out soon.
Teraz wchodzi pan Bill Nelson, który jest dyrektorem NASA. Administratorem dokładnie.
Fractions of the asteroid Bennu sample to a sample analysis team of more than 200 members from more than 35 globally distributed institutions. We're pleased to be joined by the international community with representatives from Japan Aerospace Exploration Agency and the Canadian Space Agency, who will both curate a portion of the sample for analysis. As we venture to
W ogóle
explore to deep
próbka
space,
będzie
our
też
collaborative
przekazana
international
innym agencjom, europejskiej agencji, japońskiej i
and
kanadyjskiej.
enhance peaceful relationships between our nations. We do have a lot of exciting work here at the Johnson Space Center with the intention to inspire the next generation of explorers, the Artemis generation, represented today by Houston Independent School District. Where are you guys? And the San Antonio Independent School Districts. The sample that we're going to have today will unlock new insights into the origins of our solar system and help answer ancient questions about our own planet. And a large fraction will be stored and available for future generations of scientists, and that could be one of you. I would like to also recognize we have representation here from the offices of Senator Cruz, Representative Jackson Lee, Representative Brian Babbins, Representative Weber, Representative Garcia, Representative Fletcher, also from the Office of State Senator Middleton and State Representative Bonin. And we thank them for their bipartisan support. Thank you all for being with us to witness history in the making. Osiris-Rex embarked on a 7-year journey to Bennu and back to bring us this sample. In fact, the mission
Teraz pani mówi, że misja trwała 7 lat.
This historic day has
Została
been in the making for
wystrzelona
12
7 lat temu.
Can we get a round of applause in celebration of the researchers at the University of Arizona Lunar and Planetary Laboratory, Lockheed Martin, Jacobs, the NASA workforce, and all those across the agency who came together to make this very exciting moment in history happen. Let's give them a round of applause.
Bardzo dawno temu, ponieważ sam lot trwał kilka lat.
Thank you, thank you. I hope all of you are as excited about this mission as I am. It will help scientists investigate our planet's formation and for us all to experience our next giant leap together. Thank you.
Thank you, Director Weich. A mission like OSIRIS-REx is bigger than one person, one agency, or even one nation. It takes the careful work and collaboration of hundreds of engineers, scientists, mission managers, and more. Our next guest leads the NASA center that oversaw the mission management systems engineering, safety mission assurance for OSIRIS-REx. I am pleased to introduce the director of Goddard Space Flight Center, Dr. Mackenzie Lystrup.
A to jest dyrektor Centrum Lotów w Goddard.
Hello everyone, and thank
thank you, Shaniqua, and thank you, Vanessa, for hosting us here today. This is an exciting example of NASA, one NASA center passing the baton to another.
Dr.
And
Mackenzie
really NASA at its
Listrap,
best
chyba dobrze
and most
czytam.
collaborative. You know, this mission exemplifies that collaboration is what leads
Powiedzcie,
us
chcesz, żebym
into
wyłączył
the
napisy, czy lepiej jest jednak troszeczkę z napisami?
era of sample science. This is when sample science really begins. Osiris-rex took aim at some of the biggest questions in exploration and science. You know, how did our solar system form, and how did life originate on Earth? It can't get more exciting than that. We can't answer these kinds of science questions without fantastic engineering. And I'm really proud of the team at Goddard, at Lockheed Martin, and at the University of Arizona that oversaw the mission for more than a decade. It's really scientists and engineers coming together in order to make our scientific dreams come true. It was exciting to be in Utah just a few weeks ago and seeing the moment that the capsule hit the desert floor after 7 years in space. It was an exciting moment to see, but really the real journey begins now. It's worth remembering that this team accomplished almost the impossible here, and we were able to, from the maybe back of the envelope science ideas of what OSIRIS-REx could possibly do, all the way through to conceptualizing this amazing mission, building it, testing it, launching it, going to the asteroid, taking the sample, coming back to Earth, landing in Utah, and now here at home at Johnson Space Center. This is the smallest body we've ever orbited before. At one point, it was orbiting only a radius of 0.6 of a mile. I mean, that's just walking distance. So it's really a brand new era for us at NASA, and it's the first time that the United States has brought a sample back from space and landed it safely on Earth. We've been able to map the entire surface of Bennu in detail to find the safest and best landing site, and it's really helped us understand these kinds of asteroids in more detail. But now, of course, we are going to be looking in detail for the first time at these samples. So we're at the point where we have justified all of the really hard work. And again, we're handing the baton off to the really world-class sample facility here at Johnson Space Center. So I want to give a round of applause to Johnson here.
Ciekawy jestem, kiedy przyniosą tą próbkę. Chciałbym zobaczyć, jak to wygląda wszystko.
So you hear today that our scientists are incredibly eager to get at the samples. I know that there are Goddard scientists as well who are waiting for their small piece of the sample. So over the next months and years, we're all going to be definitely rewriting some history. When we do, I want all of the team members and their families to really recognize that the revelations that we're going to make here are standing on the shoulders of the incredible engineering and science that you've all delivered. Thank you and enjoy today.
Aha, tam taka pojemnik stoi w kształcie tej kapsuły na stoliku, zauważyłem teraz. Podejrzewam, że może tam są w środku chociaż niemożliwe, muszą chyba je przynieść w pojemniku jakimś sterylnym.
Its mission is to combine scientific and engineering expertise in order to advance human space exploration, to integrate terrestrial and planetary research, and to promote successful space missions by mitigating risk. NASA has the world's leading sample scientists and creates the most extensive collection of extraterrestrial materials on Earth.
A pani mówi, że NASA ma najlepszych naukowców i największą kolekcję próbek z kosmosu.
The JAXA-led Hayabusa and Hayabusa 2 asteroid samples, and now OSIRIS-REx and the samples we collected from asteroid Bennu. Our team has been caring for the OSIRIS-REx sample and its contents since it arrived in Houston on September 25th. Now let's hear from a crucial member of the team. Please join me in welcoming Dr. Eileen Stansberry, Chief Scientist at NASA's Johnson Space Center.
O, to jest główny szef naukowców w Johnson Space Center.
Thank you. I'm honored to be here celebrating with you all today and representing science at JSC. This sample return mission is an important part of an integrated planetary exploration strategy answering fundamental questions on the formation
Że ta misja była
of our solar system.
głównym.
The pristine sample material from Bennu represents a valuable resource providing a window into the early solar system and is
Przepraszam, ale mi uciekło.
to NASA's astromaterials collections. Our role in astromaterials curation.
Troszeczkę ciężko mi jest tak tłumaczyć, jak oni na bieżąco mówią. Nie wiem, myślałem, że może da się uda wstawić jakoś napisy na przetłumaczenie, ale chyba nie ma.
Opening the science canister and methodically removing tag SAM revealed an abundance of sample from asteroid Bennu, and even though the tag SAM head is not yet open. With this abundance, we're taking our time methodically processing to properly care for every valuable piece of Bennu. And with the overflow of sample found on the avionics deck spilling out of the tag SAM, we have plenty to show you today. The science obtained during the mission so far, coupled with the samples we're only now getting a glimpse of, are just the beginning of the wealth of knowledge that we can expect from osiris-rex. Sample return missions are unique. They provide for a large...
Ciekawe, ta asteroida, jak ja czytałem o tym, to ona nie jest taką skałą, tylko to jest, jakby to powiedzieć, taka fruwająca skupisko małych kamieni, małych, dużych kamieni. Jak czytałem, jak oni uderzyli w tą asteroidę tą nogą, to musieli silniki odpalić, bo zaczęli się zapadać. Tak trochę jak wydma, jak jest piasek. Sonda dotknęła tego i zamiast odbić się, znaczy zamiast uderzyć w twardą skałę, to zaczęła się zapadać coraz głębiej i głębiej.
I'm proud of the stewardship that we commit to these samples as we begin this next phase of the mission with sample curation and scientific analysis, celebrating the legacy that the osiris-rex mission is providing to current and future generations of scientists. Let's take a look at the people and labs that are working with our newest astromaterials, the osiris-rex samples of...
Dlatego, że to jest po prostu skupisko... Oho. Za chwilkę odpowiem. O, tu jest właśnie wystrzelenie tej rakiety sondy. Ja tego nie oglądałem osobiście.
So organic compounds that could have been the building blocks for life on Earth and potentially other places in our solar system.
And some of these samples may even have remnants from before the solar system, pre-solar grains.
O, teraz tłumaczę, że ta asteroida mogła mieć skały jeszcze sprzed czasów formowania się planet i Układu Słonecznego. O tym mówię, o tym uderzeniu właśnie. To nie uderzyło twardo w skałę, tylko zaczęło się zapadać.
The study and preservation of rocks from space.
This is a group of a really diverse range of scientists and engineers that are exploring our solar system.
No i tutaj testują właśnie teraz, to są próby wszystko.
Developing things like lunar simulants, being part of NASA missions that range from the exploration of Mars, including the Curiosity and Perseverance rover, supporting the Artemis.
A oni używali takich białych kulek zamiast prawdziwych skał do próbnych badań.
Altered by the Earth's atmosphere. They have been exposed to Earth's chemical compositions. They are contaminated samples.
And in our curation labs, we carefully work on samples in clean rooms, nitrogen atmospheric glove boxes that protect the samples from Earth's atmosphere, oxygen and humidity.
You don't want to study us on samples. You want to study the actual samples in its original state. And so pristinity within curation is very important, and we go to great lengths.
O, właśnie, widzicie na takich białych kulkach.
Every time we do that kind of probing investigation, we learn something new about the nature of the universe and ourselves.
2, 1. I feel like humans, since the beginning of time, have always been explorers. We have not stayed in one place. We have
O, bracia Wright i pierwszy lot.
continents, and eventually that was going to happen with planets or asteroid bodies.
whether it's Artemis or Mars. Everything we've learned on Osiris-Rex is going to further our knowledge
Powrót kapsuły.
and technology development.
Oglądałem to, nie robiłem z tego transmisji jeszcze, ale oglądałem to.
These samples are here on Earth for future generations. 50 years from now, we can be studying these with instruments we couldn't have imagined before. So I think that's one of the most important aspects of this mission, is bringing the samples back. We've waited for 7 years, and now we can reveal what's inside.
Next up is someone who needs little introduction. He leads our agency and keeps a close eye on our efforts across the solar system. Please join me in welcoming NASA Administrator, Senator Bill Nelson.
Senator Bill Nelson. On jest głównym administratorem NASA, czyli ogółem szefem NASA.
Hey everybody, it's days like this that continue to amaze me. And what we do in this little agency, it's all amazing. I'm going back to the Cape this afternoon because we're launching a $1 billion spacecraft all the way beyond Mars, closer to Jupiter. And it's going to snuggle up next to a metallic asteroid.
Teraz mówi właśnie o misji, którą jutro będziemy swoją drogą nadawać, o Psyche, o sondzie, która poleci do metalowej asteroidy, która też się nazywa Psyche. Swoją drogą ona jest wyceniana na $1 tryliony.
And we've always been a nation that is restless unless we're pressing the unknown. For 65 years of NASA's existence, and this is our birthday, NASA has responded to America's call. And the story of this little agency is the story of technologies transformed, of barriers broken, of making the impossible possible. And so through missions like what will be Psyche, the one lifting off tomorrow, or Perseverance, the rover that is running around on Mars and digging samples in our search for life there, or the little helicopter that's now flown upwards of 60 times. We just wanted to see if a helicopter could fly in a 1% atmosphere.
Teraz właśnie mówi o małym dronie, który lata tylko na 1% atmosfery. Swoją drogą leciał 16 razy już na Marsie.
If it's the James Webb Space Telescope, look at the discoveries. We are going to have answers to questions that we don't even know what the questions are now. Everything is a new discovery as we are glimpsing the early part of the development of this magnificent thing called the universe. And now, Osiris-Rex. And it's giving us a glimpse into what lies beyond. So 7 years, almost 4 billion miles of a journey throughout the solar system to the asteroid Bennu.
4 miliardy.
Now back in Osiris-Rex, the sample return capsule.
4 miliardy kilometrów.
Landed in Utah, right on the money. It was a picture-perfect mission. It's a feat.
Przepraszam, mil chyba, on powiedział mil, nie kilometrów.
And it's NASA's first ever sample from an asteroid. So, you ready to see the results of the mission? Take a peek.
O!
So the first analysis shows samples
No i są,
that
i proszę,
contain
są próbki z
abundant
asteroidy.
in the form of hydrated clay minerals, and they contain carbon, and you could see the carbon there as both minerals and
Zawierają węgiel.
molecules.
Mówi właśnie, że tam jest bardzo dużo
And
ilości węgla.
at nearly 5% carbon by weight, carbon being the central element of life, a far
I że
exceeding
życie ogólnie bazuje na węglu.
This is the biggest
Bo taka jest prawda.
rich asteroid sample ever returned to Earth.
Najbardziej bogata w węgiel próbka, jaka kiedykolwiek wróciła.
The carbon and water molecules are exactly the kinds of material that we wanted to find. They are crucial elements in the formation of our own planet. And they're going to help us determine the origin of elements that could have led to life. And I mentioned that one of our missions, it's actually in statute, is to look for life. That's why we're digging on Mars. That's why we go out into the far regions of the very beginning, capturing light from the formation of the first galaxies with James Webb. Now we're looking at this, and what you're seeing today, there's so much more to learn, and there's so much more now
Ale
that we have
zwróćcie uwagę, jaka to jest drobnica. To jakby ktoś
to analyze.
jakiegoś żwiru nasypał. To jest, bardzo drobne są te kawałeczki.
Because at NASA, we are trying to find out who we are, what we are,
Te skały mogą być starsze niż cały Układ Słoneczny.
what is our place.
Mogą być, są starsze.
Vastness called the universe.
Albo z wczesnych,
This mission will help our
wczesnych czasów
scientists
formacji
investigate
się Układu Słonecznego.
planet formation for generations to come, and it's going to deepen our understanding of our solar system, and it's going to improve our understanding of asteroids that could threaten us here on Earth, helping us protect our planet. And oh, by the way, do you remember
Teraz mówimy właśnie o obronie przed,
we intercepted it at 7
przed asteroidami. Kiedyś była wystrzelona, jakiś czas temu, no to dłuższy czas temu, była wystrzelona misja DART do systemu. Jest asteroida, która orbituje wokół większej asteroidy, chyba Dimorphos i Didymos. Nie pamiętam, czy ona uderzyła w Dimorphos czy Didymos, nie pamiętam, która była która, ale właśnie udało się zmienić trajektorię tej asteroidy poprzez właśnie uderzenie, walnięcie tą sondą w tą asteroidę. I to już jest taki pierwszy krok właśnie w osiągnięciu ochrony jakiejś przed tego typu obiektami.
Where a team of scientists are hard at work since the sample arrived just 2 weeks ago.
O, teraz pokażą pracę tych naukowców, którzy pracują w tych clean roomach z tymi próbkami.
NASA's osiris-rex curation lead, Dr. Nicole Lunning, and we are standing just outside of the osiris-rex pristine curation clean room. Nicole, before we get started, can you tell us a little bit more about where we're standing right now?
Yeah, thank you, Courtney. So we're in front of the newest curation lab in historic Building 31, which is home to the largest collection of astromaterials in the world.
Now, the world just got its first look at this gorgeous sample. Can you tell us
cześć,
how the
Tatiana.
curation process has been going so far?
Yeah, it's been incredible so far. On Sunday, September 24th, the sample return capsule landed safely in Utah.
Właśnie tak wyglądało miejsce lądowania tej kapsuły. Ona tak sobie leżała, co ciekawe, fajnie się obróciła. Ona troszeczkę wylądowała pod kątem, ale tak się obróciła, że wygląda, jakby wylądowała idealnie prosto. To właśnie pokazali, jak oni zabezpieczyli tą kapsułę i przenieśli ją do clean roomu.
That first day, the next
To zostań z nami, pooglądaj trochę, to jest bardzo ciekawe i dziękuję za wsparcie.
And that gave us our first glimpse of the tag sam head, but also a surprise in that there was sample outside of the tag sam head within that sample canister. That was kind of an extra or bonus sample for us.
O, teraz się otworzyli.
Right here, so close to the sample with you today. So you mentioned that bonus sample. What have the initial findings been for the curation team?
Yeah, it's a combination of.
Ale mówią, że jest bogate w węgiel, nawet bardzo wygląda podobnie, kolorystycznie i...
Roughly the size of the short width of a grain of rice, which we've carefully collected and also have already allocated some to the science team, the sample analysis team, which you'll hear a little bit more about from Dante.
Musicie cię nakarmić potem spacer swoją lubą.
And of course, this is not just a NASA mission. There have been several partners along the way. Can you tell us a little bit more about how many scientists?
Ale to zawsze możesz posłuchać.
We have two incredible international partners, JAXA and CSA, and also the sample analysis team includes over 230 scientists from around the world.
To jest chyba widok z góry. Oni chyba kamerę postawili od góry w tym urządzeniu. A w ogóle fakt tego, jak to jest drobne, to jest bardzo ciekawy tego. Jak oni uderzyli tą nogą, jak oni dotknęli tą asteroidę, to się wszystko tak podniosło do góry. Przy takiej niskiej grawitacji, jaka tam panuje wokół tej asteroidy.
Very specifically for the osiris-rex sample, since the scientific goals of this mission are really tied to the building blocks of life and organics. Organic contamination was a really detailed concern to us throughout the entire.
Teraz mówi, że oni martwili się na temat organicznego zanieczyszczenia, czyli żeby nie było żadnych bakterii z ziemi na tej próbce, bo wtedy by to zanieczyściło tą próbkę i mogłoby ją potencjalnie zniszczyć. Tak mi się wydaje, przynajmniej w mojej opinii.
Into the tag sam. We're looking into the part that touched the asteroid Bennu. We're actually going to take those parts off to get a little further in so that we can then distribute that sample into bulk sample handling trays.
Czyli zbierają teraz te próbki wszystkie.
And for scientists interested, how will they eventually be able to request a sample?
So in about 6 months, we will release a sample catalog, which will give scientists from all around, even beyond the sample analysis team, enough information to start to think about what science questions they want to ask, and they can propose studies and specific quantities of sample they would like to use. And then those requests will be reviewed by a peer review allocation board. And then those who are granted their requests will get samples in the next 9 months or so.
All right, well, Nicole, thank you so much for joining us today. And as you can see, we are just beginning this process here at Johnson Space Center, but there is much more work to do. So we'll send it back to the auditorium for now.
After its 7-year journey, it's amazing to finally see a glimpse of the samples that were captured from asteroid Bennu. Not only will this mission help us dive deeper into how planets formed and how life began, it also will allow for current and future scientists to make discoveries for years to come.
Dzisiaj czytałem właśnie w jednej gazecie na temat kosmosu artykuł o tym, w ogóle 2, ale opowiem wam o tym drugim za chwilę. Jeden opowiadał o tym, że skąd wzięło się życie, że jest naukowiec, który bada, skąd wzięło się życie. Nie jak mogłoby się pojawić, tylko skąd się wzięło, co było takim pierwszym momentem tego, że życie się pojawiło na naszej planecie. A drugi to był o tym, jak wyglądałaby Ziemia rok po tym, jakby ludzie po prostu zniknęli. Tak, zniknęli i wszystko zostało tak jak stoi, to po prostu puf i ludzi nie ma. Swoją drogą w ogóle taki program był kiedyś, który pokazywał ileś lat po zagładzie ludzi.
Well, this is an example of why we do make the impossible possible. It's a team that no matter where we are, we all work together. You all know Pam Melroy and Bob Cabana, and we, the three of us, operate as a crew. It's because of that unity, that relationship, that watching each other's back, that we get so much done. And here is another example of what you've seen today. Now, I want you all to hear from the real experts. So take it away, panel.
Thank you, Administrator Nelson. Next up, we have Dr. Francis McCoven, Astro Materials Curator.
Thanks.
Kobielska, witajcie. Cześć, cześć, cześć i tobie.
NASA's Johnson Space Center. And we look forward to the exciting discoveries that are going to be made by the science team with those samples. Over the next 6 months, the curation team and the science team are going to be working closely together to develop a sample catalog.
Teraz mówią o tym, że przez następne 6 miesięcy będą badać próbkę i stworzą katalog, żeby inni naukowcy mogli później dalej studiować te próbki. Cześć, cześć Kasia.
All of this work takes place inside of a glove box. And those glove boxes are necessary to keep these samples as pristine as the day that the sample landed in Utah. Now, as you've heard, we have a bounty of sample on our hands already, and we're not even inside of TagSam. The views here are amazing of this sample, and they're only going to get better.
Jak macie jakieś pytania odnośnie tego, co oglądamy, to śmiało.
Within a clean lab is hard, challenging work, and it does not go quickly. But we need to do this right.
Kasia, oni badają próbkę, która przyleciała kilka tygodni temu z asteroidy Bennu. Próbkę, która ma wiek mniej więcej tyle z wczesnych formacji naszego Układu Słonecznego. Ona właśnie przyleciała kilka tygodni temu, a dzisiaj pierwszy raz ją pokazują do publiki.
This is the true value of sample return and of curation and keeping these samples pristine.
Sonda poleciała do asteroidy Bennu, zajęło jej to 7 lat, pobrała próbki i wróciła na Ziemię.
In fact, like all of our Astro Materials collections, the osiris-rex collection is going to be conserved so that scientists that aren't even born yet are going to have the opportunity to answer questions about our universe with these samples using technology that has not even been invented.
Asteroida się nazywa Bennu.
End of sample return broadly. And now let's hear some of those science results from the science team.
Thank you, Francis. Next up.
Teraz będę mówić o rezultatach badań.
Great job, Francis. Next up, we have Professor Dante Loretta, the principal investigator for the osiris-rex program.
All right, thank you, Shaniqua, and thank you, Administrator Nelson, and to.
To jest główny investigator odnośnie właśnie tej misji.
NASA for me, when I was a kid, was always like a guiding light, like a dream. To work for NASA meant to be part of the best, to be at the forefront of human exploration, and to see this dream coming true today is beyond words for me. So let's start out with taking a look at what we've gotten into so far. As Francis said, it's been going slow and meticulous, but the science is already starting. So if we could bring up my first graphic. So what you're seeing here on the left side is the first look.
Zobaczcie, jak to są drobinki. Jak to są malutkie w ogóle.
Protected the sample on the return journey home. And sitting inside there is the TagSam. That's the device that actually touched the surface of Bennu, collected sample, kind of like a vacuum cleaner, except in reverse, because we were in space with no air. We brought our own air and pushed that material inside. It's basically like an air filter. And the first thing we noticed was that there was black dust and particles all around the outer edge where the seal had laid down and protected that precious material. And the reason it got pushed out was
w ogóle tutaj, nie? Jaka to jest wszystko drobnica.
The Earth's atmosphere away from it, and it pushed all the dust and particles to the edge of the canister. And I drew a little white rectangle there on the deck, and that's zoomed in on the image on the right there.
A ten obrazek tutaj, to jest przybliżenie tego tutaj w prostokącie, co jest. To trochę działało jak odkurzacz, tylko w odwrotną stronę, bo nie da się wciągnąć powietrza w kosmosie. Ono wydmuchiwało powietrze w stronę tej asteroidy, podrzucając cały ten pył i te skały do środka. Działało to trochę jak filtr. Tak, te drobinki to są właśnie, to wszystko jest te asteroidy. Tutaj ten cały, trochę jak kurz.
Here I'm just showing you 4 different examples. This is taken with an electron microscope. Electrons kind of behave.
To są zdjęcia robione mikroskopem elektronowym. To jest skala, to są 2,5 nanometra. Przepraszam, nie nanometra, mikrometra.
Those are the water-bearing clay minerals, and they have this fibrous kind of structure. We call this serpentine.
Czyli przy wielkości 10 do minus 6. 10 do minus 6 metra. Dawać mi tu UFO, ale nie wolno. Tak, 7 lat. 7 lat zajęło od wystrzelenia do dotarcia do tego, do asteroidu, do powrotu.
The way that water got incorporated into solid material and then ultimately into planets, and not just Earth, but probably Venus and Mars also had abundant water as well. The next one on the upper right, you can see the hexagon. It's got that really like stop sign kind of shape, and that's characteristic of a sulfide mineral. If we could go back, yes, thank you. And sulfur is also a critical element for planetary evolution. It determines how quickly things melt, and it's also critical for biology. A lot of the amino acids that give structure to our proteins use sulfur to link and provide those bridges.
To są jakieś siarczany tutaj. Tutaj ten obrazek to jest jakiś siarczan.
Or you might know them as a lodestone. They react to the magnetic fields. The one on the lower left is framboidal.
A 2 obrazki na dole przedstawiają magnetydy.
Are plate-like, and especially those platy ones might be really important for organic evolution. They might catalyze certain reactions. So we're looking at the kinds of minerals that may have played essential roles in the origin of life on Earth. Now we can go to the next graphic. One of the coolest techniques that we have here at Johnson Space Center is X-ray computed tomography. It's like a CAT scan. So without cutting into the rock, we can actually look inside. We can see the textures and the distributions of the minerals. This helps us intelligently select areas where we want to make.
Tutaj dzięki promieniowaniom X-ray są w stanie zajrzeć do środka skały bez potrzeby rozłupywania jej i zbadać ją pod względem zawartości. Ten obrazek, ten kawałek skały ma 1 mm, to jest skala 1 mm tutaj u dołu. I te czerwone kropeczki to były te właśnie siarczany, które widzieliśmy na obrazku na poprzednich grafikach.
I've got 4 different focus boxes. Let's take a look at B. I call this one of the troublemakers. If you know the story of osiris-rex, you know just a couple days after we collected the sample, we saw material spewing out into outer space. One of the many heart-pounding moments on this mission for me. It's because these large particles got trapped in between this flap, which was designed to keep the precious sample inside. And that's generally good news, right? Because those are big particles, and there's a lot of science to be done there. In panel C, we're just looking at some of the finer grain material, and I'm particularly interested in the different reflectants. Bennu has a salt and pepper kind of texture, bright grains and dark grains, and we're seeing that. In fact, as I was zooming around these images, I felt like I was miniaturized and running around on a tiny little Bennu. Panel D there is one of the really friable looking particles. It's got this kind of hummocky texture. It looks like the dark, large boulders that dominate the surface of the asteroid. And what gets me is the similar size and the similar shapes and textures, even as we go to these smaller sizes. Bennu seems to have this kind of fractal nature. And then finally, the last panel there, panel E, just shows 2 very different kinds of rocks sitting next to each other. One of our key hypotheses is that there's 2 major different kinds of rocks on the surface of the asteroid, darker and brighter, weaker and stronger. And we may see those already represented. And just recall, this is the material that leaked out of the tag SAM when we flipped it over. Underneath that flap, there's a whole treasure chest of extraterrestrial material, and trust me, the sample science team can't wait to get their hands on it.
To do zobaczenia, Katarzyno, i zapraszam na następne. Jutro będzie kolejny, w sobotę będzie jeszcze następny stream.
Okay, thank you. So we've heard a lot of exciting stuff already about the water and how Bennu could possibly contribute to our oceans. I'm here to talk about carbon. Why is carbon so important? Well, carbon is essential for all life on Earth. We are all carbon-based. Carbon forms bonds with hydrogen, oxygen, nitrogen, and the sulfur to form prebiotic and biological compounds that are important, amino acids that are part of our proteins and enzymes. We even look for nucleobases, components of the genetic code in DNA and RNA. So exciting stuff, and one of the reasons we want to look for this material in these samples is to understand whether asteroids like Bennu could have not only delivered the water that led to our oceans, but actually seed the Earth with prebiotic chemicals, right? The building blocks of life. And this is the part I just find really exciting. So let's get right to it. The first carbon measurement was made at the Carnegie Institution for Science. We heard it from NASA administrator, about 5%. The actual number is 4.7%, close to 5%. And this was a big deal. At the time this data came back, I mean, there were scientists on the team going, wow, oh my God. And when they say that, scientist says that, wow, that's a big deal. So we were excited right away. In fact, Carnegie said this for the extraterrestrial samples they've analyzed, this is the highest abundance of carbon they've ever measured in any extraterrestrial sample. And they've analyzed close to 250 meteorites. So this is a unique sample that we're dealing with. The second measurement we made, we started to look more at what is the nature of this carbon. You're looking at an image here. Oh my gosh, this was taken in the optical microscopy lab right here at Johnson Space Center. Gorgeous image of a particle of Bennu. On the left, you see a small grain of Bennu in reflected light, visible light, like you'd see with your eye, but magnified. And on the right, you see the same grain, but under UV ultraviolet light. So this is like the crime scene investigation TV show where they go in with the black light and they look for the evidence that they can't see with their naked eye. We're doing the same thing here now, but with a 4.5 billion year old grain from the early solar system. And the stuff's lighting up. You see carbon there in the center, just to the right, the kind of a light bluish fluorescence. That's from a carbonate mineral, so carbon locked up in this.
Tu są wszystkie węglane materiały węglowe, te wszystkie małe, takie jaśniejsze plamy, to są właśnie cząstki węglowe. Zdjęcie w skali 25 mikrometrów.
But we'll be looking for these, again, biologically essential organic molecules over the next month as these samples will go out to labs around the world to study this in more detail. And I want to make just kind of one final point. We've heard about these great initial preliminary results. I know there's more to come. But osiris-rex, the team, we picked the right asteroid. And not only that, we brought back the right sample, right? This stuff is an astrobiologist's dream. You know, just can't wait to get at it, and this material will be around for generations and generations. We're going to learn so much about the origin of the solar system, the evolution, and potentially how even life started here on Earth.
Dzisiaj będą też studiować, skąd mogło się wziąć Ziemi na życie. Ziemi na życie, życie na Ziemi. Ziemi na życie.
Thank you, Shaniqua. It's such an honor to be here today, and what an incredible honor to share the stage with these amazing scientists up here.
Troszeczkę mi ciężko mówić jednocześnie, bo jestem ciekawy, co oni mają do powiedzenia. Chciałbym też wam tłumaczyć na bieżąco, jak to wszystko działa.
That's been spending incredible hours over the last 2 weeks to bring you the information that you saw today and to make these early discoveries. It's just an incredible team. They're working really hard, and we keep telling them, don't, take your time, go slow, but they're doing an amazing job. It's really incredible. But as you heard, what you're seeing here today, as exciting as this is really just the beginning. There is so much incredible work to happen. We're going to get that tag SAM opened up. We're going to get the full sample. We'll really get a full picture of what we collected and begin those amazing discoveries. But let me put osiris-rex in a little bit of context about some of the other planetary work that we're doing at NASA. So within our NASA planetary program, we actually have almost 40 missions that are exploring the solar system. Some of those are being developed, some of those are in operations. But within those almost 40 missions, we actually have 7 of those missions that are focused on understanding asteroids. And you heard from Dante about how important asteroids are for understanding the early formation of our solar system, the origin of life and water on Earth and perhaps other places in the solar system. These asteroids are really, each one of them in different parts of the solar system can give us different pieces of the puzzle about where we came from. And of those 7 missions, right now, we're really lucky because we're in the middle of what we're calling asteroid autumn. We've got several big milestones happening right now on 4 of those missions. Of course, you know we got the osiris-rex sample that landed on September 24th. Right after, 20 minutes after the entry system was released from the spacecraft, we actually transitioned that spacecraft for a new mission. It's now called Osiris-Apex.
Właśnie też teraz mówią o tym, że ta misja zmieniła nazwę na Osiris-Apex i teraz ta sonda poleciała do kolejnej asteroidy, która się nazywa Apophis, po kolejne próbki.
We celebrated the 1-year anniversary of the double asteroid redirection test, and you heard Senator Nelson at the beginning mention that. What an incredible feat that was. The first time ever for humanity to change the orbit of a celestial body.
O, to jest właśnie pokazana animacja tej misji DART, która poleciała i zmieniła trajektorię tej asteroidy, czyli to jest taki zalążek naszego pierwszego systemu obrony przed dużymi asteroidami. Ona właśnie jak tu na animacji uderzyła w tą asteroidę i zmieniła jej trajektorię.
That's going to explore a special set of asteroids that are even much further out in the solar system. They lead and trail Jupiter in its orbit around the sun, and those are called Trojan asteroids. That mission called Lucy is actually on November 1st going to fly by a main belt asteroid on its way out towards the Jupiter system. And it's going to fly by a main belt asteroid called Dinkinesh, and it's going to allow them to test out.
Właśnie w taki sposób, jak tu na tej animacji pokazane, jak są wysyłane asteroidy do różnych planet. One nie lecą po prostej drodze, one właśnie lecą takimi okręgami wokół orbity razem z Ziemią, potem na przykład przeskakują do Marsa i dzięki grawitacjom tych planet one utrzymują prędkość, przy tym oszczędzając paliwo, bo nie byłoby możliwe wysłanie w ten sposób tych sond. A tu jest animacja tego, co będziemy jutro oglądać jutro. To jest właśnie asteroida Psyche i ta sonda też się nazywa Psyche. I jutro będzie też z tego transmisja na żywo. Właśnie będziemy oglądać start tej rakiety i start tej misji. I będziemy ją w sumie śledzić na bieżąco. Ja będę też informował, co się z nią dzieje na postach na moim, w karcie społeczności na moim kanale.
Thank you. Thank you, panelists. We will now move on to our Q&A segment. We'll be taking questions from media in the room and students from the Houston and San Antonio Independent School Districts. We'll take our first question from media. If you'll come to the mic one at a time, you'll be able to state your name and affiliation. And if you know where your question is going, please direct it to one of our panelists.
Hi, I'm Andrea Leinfelder of the Houston Chronicle. I have a question about the tag SAM. Did you guys expect it to be open by now? And has there been any reason it's not open? Have you run into any problems?
A misja, którą będziemy jutro, będzie trwała około 2 lat. Ale ona nie zbiera próbek z tego metalowego świata. Ona będzie robić tylko zdjęcia i badać kompozycję tej asteroidy.
It's taking us a little longer to get inside, but the view so far is amazing.
Our next question we'll take from students. If you come up to the mic and tell us your name, grade and school.
O, teraz wołają studentów i teraz w ogóle jest pytania. O, studenci właśnie z college'u zadają pytania teraz.
I'm Alison Cordova. I'm in 6th grade from D Middle School, and my question is, do you think the samples got affected from the heat when entering our atmosphere?
Pytanie było, czy asteroida została w jakiś sposób uszkodzona poprzez temperaturę przy wejściu w atmosferę ziemską. I teraz ten pan pokazuje tę białą kopułkę, co tu jest. To jest, o właśnie tak wygląda kapsuła i to jest ochrona przed właśnie temperaturą. Jak ona ląduje, wchodzi w atmosferę i zaczyna się nagrzewać, to właśnie to miało chronić te próbki w środku.
We'll take our next media question.
Hi, Eric Berger with Ars Technica. Congratulations, those were some pretty stunning images of what we saw. I guess my question is for Dante Loretta. Just, I know you haven't opened up the TAGSAM to look at all the rocks and hopefully inside, but I'm sure you've done a mass analysis of the spacecraft versus, you know, what you've got now. And so just, what is the estimate of the total amount collected versus the minimum goal of 60 grams?
Great, thanks Eric. Great to see you here. So we were able to do a mass estimate in flight.
Ogólnie teraz mówią, że udało się zebrać 60 gram tych skał, te próbki łącznie.
The filter was at the end of a long robotic arm, about 9 feet long. And as we moved that arm before sampling and after sampling, we were able to look at a property called momentum that was transferred between the arm and the spacecraft. There's special components called reaction wheels, which will take up that momentum. And we looked at that difference and we estimated about 250 grams or about 8.8 ounces of material.
Nie, przepraszam, 250 gram się udało zebrać, przepraszam, 250.
Still to be revealed inside TAGSAM, but of course the proof will be when we open it up and we actually get it on a balance here in our Earth's gravity field and get that real number for you.
All right, we'll take our next student question.
Hello, I'm Raj Sinha from Houston, Texas. I am a junior at Langham Creek High School and a NASA Seas High School intern. And this is a question for anyone. What are the broader implications of the osiris-rex mission for our understanding of asteroids, the early solar system, and potentially hazardous space objects?
Well, you think about the formation of the universe and then the formation of our solar system. And there's this gas and this dust that's all swirling and things start to be created and then all of these things start running into each other and out of it come stars and then lesser celestial bodies start.
Bill Nelson krótko opisuje, jak powstają w ogóle planety i gwiazdy w kosmosie, nie? Na przykład nasze planety powstały przez to, że materia, która wirowała kręciła się wokół Słońca, zaczęła się w końcu ze sobą łączyć. Mniejsze skałki, większe skałki, jeszcze większe w protoplanety. Protoplanety zbierają coraz więcej i więcej materiału, zmieniały się w planety. Zmieniały, rosły do takiej wielkości, że stawały się planetami.
And this, by the way, is fulfilling part of our destiny. And part of our destiny is that we are explorers, we are adventurers. We want to know what's over there in order to know why we're here.
All right, we'll take our next media question, please.
Hi, I'm Mike Prokosh. I'm with the NASA Social and the same Houston State University. And I was wondering, how did the rotation rate of the asteroid influence the choice of the landing zone?
Great question. So one of the criteria when we selected the target for the mission was its rotation rate, because if an asteroid is spinning too quickly, being able to match that velocity and make a safe contact with the surface would have been impossible or really, really difficult. So it was originally when we were going through the million.
Teraz mówię o tym, jak obracanie się asteroidy wpłynęło na wybór miejsca lądowania na niej.
About 10 centimeters per second, so just a few inches per second, so really slow relative to what we can do with the spacecraft. And at the end, right before
Asteroida obraca się z prędkością 10 centymetrów. 10 centymetrów na sekundę? Na sekundę tam było chyba, nie? To w sumie nie tak szybko. Bardzo wolno w sumie, szczerze mówiąc.
My name is James Johnston. I'm a senior in high school, and I go to CETA High School at Roosevelt in San Antonio. My question is, where did the Bennu asteroid come from?
Where did Bennu come from? Maybe it's a Danny.
Great question.
No, pytanie, skąd się wzięła asteroida Bennu? Chyba się uformowała. Oni właśnie to próbują badać, z czego ona się wzięła. Tam właśnie teraz odpowiedzieli.
The outer parts of the asteroid belt, and then was broken apart, right, by an impact, and we're looking at kind of the remnants of that, a rubble pile, if you will. So some of those pieces came back together, and then it ended up, you know, kind of in this near-Earth orbit. But we're trying to figure out really the history of that process, when those things happened, where it originated. It's part of our major science goals here, and by studying these samples, we're going to be able to answer that question in more detail than I can give you right now.
Next media question.
Hi, Kaylee Brower with NASA Social and Harvard Smithsonian. I was curious about the appeal of the larger rock samples, such as the one trapped under the flap on the canister, versus the smaller dust and rock samples.
Yeah, I'll take that. So we're excited about the whole size range of what we see there, because that'll tell us about the different formation mechanisms of the stones. So the big ones are really good because you get the minerals in context to each other, which mineral is next to which one. That'll give you some indication of the chemistry that happened inside the asteroid. Minerals will convert when the water hits them. You take a normal rock and you add water and you get the clays. And we might even see the original rock inside, and that where the water was reacting, and that might be frozen. So it gives you that context and that big picture. The fine particles I'm particularly excited about because I think they were bigger stones when they were on Bennu in the microgravity environment. And then when they got to Earth's gravity, it just crushed and fell. And something like that would not make it to the surface of the Earth as a meteorite. And so that, to me, as I grew up studying meteorites, you know, in college and in graduate school, so to have something from space that we've never seen in our laboratories, there's nothing more exciting. No matter what it is, the fact that it's new has got us really anxious to get that material into our instruments.
All right, we'll take another student question.
Hello, I am Aaron Kingsland from Lavernia, Texas, a junior at Idea Carver College Preparatory School and a NASA Seas high school intern. My question is, what ripple effects do you anticipate the osiris-rex accomplishment will provide for both space exploration and our world, given the historical precedent of space achievements driving unexpected advancements in various fields?
At NASA, we're doing 100 things at once. And this is just one example. Dr. Glaze mentioned a whole bunch of others, but we haven't even talked about what is one of the primary purposes of the Johnson Space Center, which is human spaceflight. Look at the breakthroughs that are coming now, finally coming to fruition in pharmaceutical research on the International Space Station. It's just unbelievable. Now we are going back to the moon after a half century, not just to go to the moon. We're going back to the moon in order to learn, to live, to create, to invent, in order to go to Mars and then beyond with human beings. Again, it's part
Właśnie NASA będzie chciała ustanowić jakiś stały pobyt na tym, na Księżycu teraz, o tym mówią, ale mi się wydaje, że chyba Chińczycy będą szybsi niż Stany Zjednoczone. To będzie swoją drogą ciekawy wyścig do obserwowania i ciekawe czasy. Chińczycy ostatnio w wiadomościach pokazywali swoje pierwsze koncepty, jakiś baz na Księżycu. Też jest plan budowania teleskopu na Księżycu, to swoją drogą też by było bardzo przydatne według mnie.
Now we are playing the discovery in such a large playfield called the universe. And we find from James Webb, we find that after a NASA scientist who got the Nobel Prize, by the way, discovered that the universe is 13.8 billion years, we are beginning to see that light as a result of the telescope. A million miles from Earth, we're beginning to see that light in the formation of that first galaxy. So there's still so much more to discover.
To jest ciekawe, że im dalej patrzymy w kosmos, tym bardziej patrzymy w przeszłość. Im dalsze galaktyki udaje nam się zaobserwować, to znaczy, że te galaktyki formowały się na samym początku nazwę życia naszego wszechświata.
It was mentioned that 3 samples or some amount of samples are going to be going to 3 museums for the public to see and sharing the excitement of this. Can you explain a little bit, given how there's an apparent excitement about even the small of the samples, how you go about picking what to send to a museum or what to give to JAXA, what to give to CSA? How are you going to divide the sample? Yep, so I can take that one.
Teraz pytanie padło, jak podzielą między różnymi agencjami te próbki.
We've got processes set up where representatives from the Canadian Space Agency and JAXA are going to come and look at the sample along with the team, and as a team we're going to look at everything and basically pick out.
To jest taka, że właśnie wszystkie te agencje przyślą naukowców, którzy będą mogli sobie zbadać te próbki.
And it's, you know, everyone basically in the lab looking at the material directly.
Aha, czyli oni chyba nie dadzą im jako tako do badania do laboratorium, tylko oni będą mogli sobie po prostu przyjechać i zobaczyć. Ale w sumie miałoby to sens, bo transportowanie tych wszystkich próbek mogłoby być
of any type of thing before we start using it for something else. And those are the samples that are going to go to the museum.
Mogło być przynajmniej ciężkie.
They're going to be amazing. I can't wait to have the public get an opportunity to look at these beautiful samples.
All right. Let's go to our next student.
Hi, my name is Kylie Mays, and I'm from DD Middle School, and I want to ask, what does Bennu mean, and why did you pick Bennu from all the other asteroids?
Pytanie padło, czemu akurat asteroida Bennu? Wybrana, już wybrali w 2005 roku, tutaj właśnie jest mówione. Zostało wybrane na podstawie tego, że jest najbliżej.
But that was going to take a couple decades, and as long as I've been working on this, I wanted to try to make it as efficient as possible. We didn't want to get too close to the sun because things get really hot, like the Parker Solar Probe has all kinds of special equipment to survive touching the surface.
Też nie, może nie za blisko Słońca, żeby nie było za gorąco, żeby byłoby o wiele drożej zbudować taką sondę, która mogłaby podlecieć blisko Słońca. Nie za daleko, żeby też żeby dało radę napędzić tą sondę, dlatego że nas napędza na światłem słonecznym.
And then we're bringing this capsule back, and we couldn't come in too fast, so we needed an asteroid whose orbit would allow us to come in slow enough that that heat shield could protect the sample. After all of the engineering was done, we went to the size. We wanted something kind of big because we thought it'd have a better chance of having loose material on the surface. And then finally, science got to come in and say, we want the carbon. Carbon is the #1 goal of this mission, and so we picked the asteroid we hoped had the most chance of being carbon rich, and as you heard from Dr. Glavin, that's exactly what we got.
All right, we'll take another one from media.
Thank you, Mark Carreau with Aviation Week and Space Technology. Have you estimated the mass of material outside the taxam that you've assessed so far? And is that part of the overall 250 grams, or is that separate, additional?
So for what we weighed so far on the material from the avionics deck, we're just under 1.5 grams of material. We haven't weighed the material that's sitting on top of the Mylar flap with all the beautiful images that you've seen today. And the thing with the particles that we've measured so far, some of the larger ones weighed less than we thought, and some of the smaller ones weighed more than we thought. And so it's really hard to estimate the mass based on what we can see, but what I can tell you is that I'm very excited about the volume of sample that we can see now.
Thank you. Our next student question.
Hello, my name is Brendan Cody. I am an 8th grader at Kruger Middle School. My question is, Will the samples of Bennu give us any advantages?
Pytanie, czy badanie asteroidy Bennu nam się na coś przyda?
It's an interesting way to phrase the question. I think that as humanity, yes.
Czy da nam jakieś takie... Jak to przetłumaczyć? Czy jakoś nas popchnie do przodu w ten sposób? Jakieś korzyści z tego?
And I think that's for all of humanity. And I don't, you've heard we have some amazing international partners on this mission. So it's not just the United States. This is an international endeavor. You've heard that the samples, our sample team, just the science team, is made up of over 200 people in 35 nations. So we've got an incredible, spread of this knowledge, I think. And then we'll also, as you heard, we're going to have a catalog that'll be open to the entire world to study those samples. So to me, the advantage that we have is really just in the knowledge that we're all going to gain.
All right, well, next up for media, please.
Hello. Hi. My name is Rindel Papa. I'm with NASA Social. First, thank you for all your insights and hard efforts over these past 12 years. Regarding the landing site for Nightingale, there was a surprising impact and shift. So has that determined or adjusted your impact for how you're going to select asteroid missions in the future?
Do you want me to take that one? I think that was one of the most amazing things, right, about Bennu. Number one is that it just kept surprising us and surprising us and surprising us. So the fact that when we went to take the sample, that when you see the animations and you actually see the video, real-time video of the descent, it just kept going. We expected there to be some resistance, and it wasn't there. And so that really tells us a lot about kind of the physical properties of this type of what we call a rubble pile asteroid. And that's really important as we start thinking about future planetary defense missions. So we talked about the DART mission, the Double Asteroid Redirection Test mission. As we start to look at asteroids that are potentially hazardous, one of the things we really want to know is it a dense, monolithic rock, or is it just this loose collection of debris? And having the physical properties that we've gotten from Bennu will really help us understand and think about how we model what the potential dangers could be from asteroids. We've actually learned an incredible amount from Bennu that's going to help us in defending our planet in the future.
We'll go to another student.
Hello, my name is Michael Alexander Cruz. I am from the district HISD. My school is Dedi Middle School. My question is, how big is the team that built and designed osiris-rex?
Pytanie było, ile osób budowało sondę osiris-rex?
Things about leading a program like this is the team, and it makes it all worthwhile. We've heard it many times from the administrator, from Dr. Glaze, that it's the team that really makes these missions succeed. And quite honestly, it's the best part of being a part of a program like this, because it's much bigger than any one person. I can tell you at the peak when we were building the spacecraft back in 2015, there were over 450 people full-time on the program.
Najwięcej osób w piku pracowało, 450 osób przy tej sondzie. Nie licząc wszystkich kontraktowców albo tych dostarczycieli. Ze wszystkimi razem ponad 1000 osób.
We have one unifying identity, and that is osiris-rex.
Thank you. All right, we'll go to our next media question. Please remember to state your name and affiliation.
Hi, my name's Josiah Horniman with NASA Social. You showed us some incredible images from the electron microscopy of different minerals. The iron oxide and magnetite in particular were very cool. Is there any planned analysis of the magnetic fields that might be frozen in those? And if so, are there any results there that might excite you?
That's a really important question, because I know there are a lot of scientists that are interested in possibly recording magnetic fields. One of the challenges is that there was a motor on the wrist of the TAGSAM that moved the head to position it for sampling and then for stow and for photography. and that's going to imprint a magnetic field on top of the sample. So we did not maintain magnetic cleanliness. When you're going through a program like this, you have to trade different things, and trying to keep the sample magnetically clean, we deemed not within the resources that we had available for the program. So the sample analysis plan that we produced does not have magnetic field measurements, but as we've heard, in just a few short months, these are going to be available to the whole world. And I'm sure there's people that are smarter than me that know how to overcome the magnetic issues that were the result of the spacecraft design, and we'll go after that problem. But it's not part of our initial sample analysis plan.
Thank you. All right, we'll go to the next student question.
Hi, my name is Tadeo Garcia. I'm from Didi Middle School, and my question is, ¿cómo consiguieron con el nombre de osiris-rex? How did they come up with osiris-rex name?
I'll take that one's my fault. Okay. But when I was first invited onto this program in 2004.
Znaczy tego nie przetłumaczę, bo on po hiszpańsku zadał pytanie. Ktoś może na czacie zna hiszpański?
Really didn't know what I was getting into. But what Mike said was, Dante, I want you to lead the science on this program. And he said he would deal with NASA and the government and administrators and budgets and all that stuff that I ended up doing. But the early promise was that I was going to be in charge of the science, and I wrote down 4 words that I thought captured.
Pytanie chyba tyczyło się właśnie tego pana, że jak on stał się szefem, prowadzącym naukowcem w tej misji.
Asteroids mostly with telescopes, and spectroscopy is what happens when you take light and you break it like through a prism into its different colors, and the way it reflects at each color tells you about the minerals on the surface. And by bringing a sample back, we can tell, did we get it right or not? And by the way, we did. We predicted clay minerals, iron oxides, carbon-rich minerals, and organics from our spectral instruments on the spacecraft, and we've seen all of those already in the sample. Then I wrote down resources, because I was thinking, I'm a science fiction fan, I'm thinking asteroid mining, maybe somebody will use the osiris-rex information to go and start furthering human exploration by using the resources that are there in outer space. And the last thing I wrote down was security, because Bennu is a potentially hazardous asteroid. We heard about the Great Dart mission, which is developing planetary defense technologies. And I said, oh, I got OSRS. If I just buy a couple vowels, I can get Osiris. So spectroscopy became spectral interpretation, resources became resource identification. And then as the mission grew and got bigger, I decided we needed something stronger than just Osiris. And somebody, almost as a joke, said osiris-rex, and we all laughed. And then I went home that night and I was like, that sounds really cool. And so I was like, we gotta be osiris-rex. And I came up with my backronym, which is the regolith explorer. Regolith is what we call the loose material on the surface of these airless bodies. And osiris-rex was born.
All right, let's go to our next media question.
Good morning, Sophie Sanchez with Casvic Chicago. Dante, I want to thank you for demonstrating right now how important it is to have an imagination and use it in scientific investigations. Based on that, y'all mentioned that analysis isn't limited by the questions asked at the mission conception. Are there any significant tech or methods, changes that have already happened, or new questions that you guys are already asking? And then if I could ask each of you to use your imagination and share with us any tech or methods that you would love to see in the future as we continue to explore space. Thank you.
Okay, I'll start with that. Yeah, absolutely. Our sample analysis plan is going to be changing and modifying in the future, especially as we make new discoveries and then ask new questions. I mentioned the building blocks of life, you know, amino acids that make up proteins, but what I'm really interested in is, you know, how far did that chemistry go on the asteroid? How much closer to life did it get? So looking, instead of individual amino acids, looking for peptides, maybe chains of amino acids. And we now have the analytical tools that actually we didn't really have when this mission was proposed to actually make those sensitive measurements of peptides. So that's personally something that I'm excited about doing when these samples get to Goddard. We'll be making, we call it Bennu tea, and extracting these compounds and looking for these peptides as well. So stay tuned for that.
So I'll use my imagination here, so which is what I love to do. So when I think of Bennu, you know, a lot of people that I meet just in everyday life, they're like, why are you so interested in rocks, right? Like, what is so cool about them? I'm like, because rocks tell you a story, right? And it's the story of Bennu and the history of the solar system that I'm most excited to unravel with this science program. And when we look at the materials, these clay minerals, these carbonates, you had a lot of water moving around in the early solar system beyond what we really expected from our meteorite investigations. You know, when we look at meteorites, we think water moving in very tiny scales, but I imagine a world right at the beginning of the solar system, right in that protoplanetary disk, where you had a lot of ice and a lot of rock and metal and carbon, and radioactivity started heating these things up, and you got massive circulation, what we call a convecting ball of mud, hundreds of miles across, right? And it's in that environment that I imagine these carbon atoms going through the first stages to the origin of life. And to me, that's the greatest mystery that we're facing right now, is like, how do you go from a ball of mud to something that's alive? Like, what happens when you make that transition? And the deepest, you know, desire is that we're gonna make some progress in trying to figure out, what is it? Why is it that we're here, we're alive, we're conscious in this universe? It's such a gift that I hope everybody really stops and thinks about it every once in a while, no matter what your problems are in everyday life. The fact that you're alive and that you're aware on this beautiful planet is something you should be grateful for every day. And that's really where I hope my imagination takes everybody.
Tak, ja tak jestem cicho, bo ja też sam oglądam i chłonę to wszystko. A też nie ma za bardzo o czym omawiać, bo jest tu już same rozmowy jak na razie. Znaczy jesteśmy w etapie Q&A, czyli pytań i odpowiedzi, więc na razie po prostu cieszmy się rozmowami.
One of the great things about curating samples and keeping them as pristine as the day that they're returned is that people, maybe yourself one day, maybe any of the students in this audience, maybe people who aren't even born yet, are going to have the opportunity to use their imagination and the technologies of their time to answer questions that we just can't answer right now with these samples. It's one of the best gifts of sample return.
I'll piggyback onto that and tell you that, you know, we brought samples back from the moon over a half century ago. I have just seen at a university where samples have been distributed to that university from each of 4 Apollo landings, and indeed they are growing plants in the lunar regolith. So who knows what we're going to be doing with these samples as we continue to learn in the future from this asteroid.
And can I just also build a little bit on what has both just been said here? You know, Administrator Nelson mentioned these Apollo samples that were collected, you know, over half a century ago. We actually just opened up one of those samples that had been held in a pristine state that entire time. And just a couple years ago, we opened that sample. We were able to open it and offer it up to scientists around the world to look at that weren't around during the Apollo days. And they have new ideas about what the nature of the moon is. At the time those samples were collected, we thought the moon was a dry and desolate place, and now we know that there's actually water contained in some of those minerals, and that there's perhaps even water beneath some of the rocks in the permanently shadowed craters. And so being able to have a new generation of scientists using the state-of-the-art instruments of today to examine those samples with new questions that people didn't even know were going to be questions at the time they were collected really demonstrates, I think, in a really real way, just exactly what we're going to see with the osiris-rex samples decades into the future.
Thank you. All right, we'll go to the media.
Allison McGrath, NASA Social, Texas A&M University. I was wondering if one of the meteorite people could comment how rare or common that magnetite framboid mineral is in our meteorite collection.
Sure. Hi, Allison. Good to see you. The magnetite that we're seeing in these structures, the framboids and the plaquettes, that is characteristic of a type of meteorite we call type 1, which is the most hydrated, the most volatile rich, very important kind of material because it's close in composition to the photosphere of the sun. which means it probably represents the bulk composition of the protoplanetary disk, the material that everything was formed out of. And then fractionation took place as different high temperature minerals formed, or you had melting occur. So it does look really like something that would precipitate out of liquid water. And that is one of our clues, along with the water-bearing clay minerals and the carbonate minerals, that we are dealing with a very wet environment early in the solar system. And of course, there's a lot of work to go to dig into those minerals and get the details and the story to pull out the history that's locked inside those grains.
All right, we're going to our final 2 questions, one from the student and one from media. We'll take our student question right now.
Hi, my name is Donald.
No, chyba zbliżamy się powoli do końca, bo już się pytania kończą.
And my question is, how will osiris-rex help us prevent future asteroids from impacting the Earth?
That's an excellent question, and I'm going to take a stab at this, although Dante's going to jump in and correct me. But one of the things that we were able to do with the osiris-rex mission when the spacecraft was there orbiting the asteroid itself was measure a very, very small force that acts on the asteroids. So we know that gravity is going to determine kind of the large orbital parameters and to help us predict where the asteroids are going to go. But it turns out that when the sun is heating up one side of the asteroid, and then the asteroid turns and rotates, and that heat is radiated out into the dark space, that also puts a little tiny force on the asteroid. And that particular effect, it's called Yarkovsky effect. You can impress your friends with that later if you like. But knowing what that little tiny force is and how that operates over a very, very long period of time is really important for helping us be able to predict when a particular asteroid might be dangerous. What we really want to know is if an asteroid is going to cross over Earth's orbit at the same time that we're in that place. And we want to not be in that place when the asteroid comes by. So being able to precisely predict that is really important. Sorry, Dante, you want to add to that?
No, that was great. I do want to add, I think one of the most important things from osiris-rex is the amazing flight dynamics team and the precision with which they were able to design the maneuvers around Bennu. It's unprecedented in spaceflight, and I don't think that gets out enough, but just the technology to rendezvous with an asteroid like this and to get the spacecraft into precise locations to get the exact data that we needed for our site selection and to unravel the geologic history of the asteroid is amazing. And by the way, we have 2 Guinness World Records celebrating those accomplishments. So just that knowledge alone is going to be essential for humanity as we go out to deal with one of these objects that might be on a collision course with the Earth. So I do want a round of applause for the flight dynamics team, by the way. They're my heroes, for sure.
All right, and now we'll take our final question from media.
Hi everyone, my name is Alyssa Luongo. I'm with NASA Social and I'm here representing Space Foundation. So us media professionals have been using hashtag to Bennu and back, and I'm wondering if there's going to be a hashtag back to Bennu or if you guys are moving on to other asteroids.
I'll take that one. So we find asteroids in a lot of diverse parts of our solar system, and each of those different populations can tell us different things. While it may be interesting to go back to Bennu, I think my expectation is we're going to keep sampling different parts of that story, different types of asteroids that can tell us different things about that origin story. Dante was talking about what that was like in the earliest times, but each one of those different asteroid populations can tell us something different. And there's a whole host of asteroid types that we haven't visited yet, so we really want to make sure we complete our sample.
And just a quick follow-up on that. I actually hope we don't have to go back to Bennu, because it means it probably is on a collision course, right? You have to deflect it. So just to clarify.
And to note, it's not. In the next over 100 years, well over 100 years before it even is potentially close, so don't worry.
Mówią o tym, że ta asteroida Bennu dopiero za 100 lat będzie potencjalnym zagrożeniem dla Ziemi, ale tylko w małym stopniu potencjalnym.
And thank you for explaining it so well. I want to particularly say to the students here, it wasn't too long ago, a decade ago, that people were actually belittling the fact that we would go to an asteroid, or the thought of capturing an asteroid and bring it closer where we might examine it. There are always going to be naysayers. Just think what Copernicus and Galileo faced when they dared to think that something was new and different and wanted to explore. So the message for you students is you're in the golden age of space exploration. Don't let anybody deter you. Keep on it.
All right. Thank you all for your questions. This now concludes our osiris-rex sample reveal event. We appreciate
No, czyli to już jest koniec tej transmisji.
Please remember there's a lot more to come and to see from osiris-rex.
Już właśnie mówią, że to już jest koniec tego eventu.
www.nasa.gov/osiris-rex or scan the QR code on the screen.
Stronę na ostatnich Astro pogaduchach żeśmy omawiali.
To 2025,
Przepraszam.
the science team will characterize the samples and conduct the analysis needed to meet the mission's science goals. NASA will preserve at least 70% of the sample at Johnson Space Center for further research by scientists worldwide, including...
A nie, czyli one jednak będą przetransportowane i NASA będzie miała 70% tych próbek.
And for humanity. Thank you all for joining us today. That concludes our program.
No i to by było na tyle z tego eventu. Ciekawe. Ja powiem szczerze, że się jaram. Bo to jest pierwsza taka misja Stanów Zjednoczonych właśnie, która wróciła z próbkami asteroidy. Co, mam nadzieję, że wam się podobało to. Ja tak troszeczkę cicho byłem, dlatego że nie chciałem gadać na transmisji z tego względu, żeby nie zagłuszać tego. O, tu mamy ładne zdjęcia. Nie chciałem dużo gadać na tej transmisji, dlatego że po prostu nie chciałem zagłuszać tego, to po pierwsze. Po drugie, ciężko mi jest jednocześnie tłumaczyć i czytać i czytać czat i tego. Wolałem po prostu odpowiadać na wasze pytania na czacie, jeżeli mielibyście jakieś zadania, ale oglądanie zostawiłem też dla wszystkich. Bardziej chodzi mi o to, że po prostu nie wtrącałem się między słowa, jakśmy oglądali tą transmisję. Wolałem po prostu odpowiadać na pytania wasze i tyle. Jutro będzie start misji Psyche. Też sobie obejrzymy wystrzał tej rakiety. I co? I jutro będzie stream. On zaczyna się o 14:30, ale mi się nie uda zacząć tego streamu o tej godzinie, z tego względu, że kończę pracę o 14:00. Zanim wrócę do domu, zanim się przebiorę z ubrań robotniczych, to też troszeczkę minie, więc ustawiłem ją na 15 minut później. Myślę, że rakieta nie poleci po 15 minutach. Podejrzewam, że będziemy czekali do godziny przynajmniej, tak mi się wydaje. Zawsze tak jest, że oni zaczynają transmisję tak godzina wcześniej, nie? Zależy ile to będzie trwało. Jeżeli będzie trwało długo, to sobie posiedzimy, porozmawiamy razem, posłuchamy ewentualnie co mają ciekawego do powiedzenia podczas tej takiej przedmowy przed lotem, nie? I poczekam sobie do samego lotu i zobaczymy, czy ta misja się powiedzie tak, jak powinno pójść. Będzie ją wynosiła rakieta SpaceX Falcon Heavy. Także nie mogę się doczekać. Tak jak mówię, tym odkryciem tych próbek też się jaram, bo naprawdę to wyglądało jak drobniutki piasek. Na początku myślałem, że to jak żwir, ale to jak piasek dosłownie. Tam kilka tych skałek i to wszystko. No dobra, no to chyba to my też będziemy już kończyć. To co, widzimy się na streamie jutro. Zapraszam Was na tego streama. Jak Wam się podobało, to zostawcie mi łapeczkę w górę. Bardzo mi to pomaga też właśnie, żeby dalej nakręcać. Zostawcie suba, jeżeli jeszcze tego nie zrobiliście. No i kliknijcie dzwoneczek, wtedy będziecie mieli powiadomienia o wszystkich moich przyszłych transmisjach i o moich filmach, które ja wrzucam. Także to wszystko. To do zobaczenia na następnej transmisji i cześć.